experiment is on drawing the characteristics curve of reciprocating pump. Aim of this reciprocating pump is to study the performance characteristics of a reciprocating pump and to determine the characteristics with maximum efficiency of the reciprocating pump. So in this equipment we need the apparatus required. So first of all the reciprocating pump, then meter scale, and then stopwatch. This is a requirement of apparatus. Then we have to see the experiment. This experiment is having reciprocating pump. This pump is having two type of pipes. One is the suction pipe. This is the black color. So this is measured vacuum pump meter. So next one discharge pipe. This is the red color pipe. This is a high pressure indicator meter. So this is a delivery controlled valve. This valve always I denoted. So anti-clockwise is open, clockwise is closed. Okay. So just follow this one to control the outlet of the discharge. Okay. So this is a construction of the equipment. Okay. So from that equipment you take the readings. This is a diagram of the reciprocating pump. So all the denoted parts are in your diagram. So this is a panel board, reciprocating pump, motor, gear valve, so and then collecting tank, gauge class scale, and then supply tank. Everything should be in the diagram. You have to see the tabulation of your experiment. So first of all the observation and result of the tabulation. So length of the collecting tank, this is the breadth of the collecting tank. So already know about the centrifugal pump. Okay. Next one, stroke length of the centrifugal pump and speed of the crank speed of the reciprocating pump. So this is a noted value from the experiment. Okay. So next one, this is a serial number. This is a pressure gauge reading. This one vacuum gauge reading or suction pipe reading. This is a total head of the water. So added the pressure gauge value and the vacuum gauge value. This is a total head value. Okay. Next one, time taken for the 10 cm rise of water in the collecting tank or storage tank. So this is a time taken for the 10 revolution of energy meter or 10 red blink of the energy meter. Okay. So this is the old one. This now in your latest one you having the 10 red blink. You have to take the time. So next one, actual discharge of the machine. This is calculated from the readings. From that reading to calculate the total discharge, actual discharge. So next column you have show the theoretical discharge. This is calculated from the specific weight of the water and then specific head of the water. From that value you know the theoretical discharge. Then percentage of the slip to calculate it from the formula. So input power of the motor is calculated from the given formula. The output power is also calculated from this formula, as well as to finally calculate the efficiency of the reciprocating pump. So this is a formula. From that formula you calculate the actual discharge of the water. So Q actual is equal to A into R divided by T. So that is a unit of meter cube per second. Okay. So where is the area of the collecting tank? A is equal to length into breadth. Already you have to measure in your experiment. So then height of the collecting water tank is already you know decided 10 centimeter. That is in converted into meter, that is a 0.1 meter. Okay. So next 10 centimeter of rights of water. How much amount of time taken in your collecting tank? That should be mentioned small t. So from that parameter to calculate the actual theoretical discharge of the water. Theoretical discharge is A into Ln divided by 60 meter cube per second. So A is the cross section of the cylinder. So the cross section of the cylinder is calculated by A is equal to pi by 4 d square. This is a circular diameter of the pipe area. Then stroke length of the reciprocating pump. Then crank speed of next the diameter of the pipe. Okay. From that parameter to calculate the theoretical value of the discharge. So next one, slip calculation. Slip is equal to theoretical discharge minus actual discharge divided by theoretical discharge. This is a percentage of the slip. Okay. So next one, input power. So this input power calculated by the energy meter. So input power is equal to 3600 into NR into 1000 divided by NC into T. So this in terms of denoted by watts. Okay, so where this NR is equal to number of revolution of the energy meter disk. So I already mentioned. So this energy meter is a old one. Old meter is a 10 revolution of disk. But now we are using the latest energy meter, that is a 10 blink of time should be taken. Okay, next one, energy meter is constant of 1600 revolution, okay, per kilowatt per hour. Okay, next one, time taken for the revolution, NR is equal to revolutions. Okay, that is converted into seconds. Okay, so this parameter I apply the input of the power, so you will calculate the input power. Okay, so that's mentioned in your tabular column. Okay, next one, output power of the power is P naught is equal to rho into G into Q into H divided by 1000 N. Okay, 1000 Newton second per second kilowatt. Okay, so from that parameter to apply the output power calculation to finally get the output power, that is mentioned into tabular column. So this total head is suction head plus delivery head equal to total head of the discharge. Okay, from that formula to calculate the total head of the, finally you get the efficiency. Efficiency is output power divided by input power into 100%. So this is converted into percentage. That is the efficiency. From that efficiency to find out the reciprocating pump performance. Now we can see the reciprocating pump, how to take the reading of your experiment. Okay, so first you switch on the machine, the red color light is on, then you have the starter. So starter is push the green color button, so your machine is on. Okay, after the machine is on, so there your discharge outlet discharges will fully open. Okay, so at the time to measure the discharge of the pressure and then suction pressure, you note it down. This is the first reading of the experiment. So next you have to measure the collecting tank area. Okay, so get the collecting tank gate wall is closed condition. After closing the collecting tank, this water is rise. Okay, so up to the 10 centimeter of the reading. Okay, so side by side we will mention the time. Okay, after reaching the 10 centimeter of rise, your stopwatch is switched off. Then how much amount of the time is taken. Okay, that will be noted in your tabular column. Then you have to measure the 10 blink of energy meter time. Okay, so the time is noted in your tabular column. Okay, so after getting, this is the first experiment of reciprocating pump. So go to next experiment. So how to change the experiment value. So you use the clockwise direction of the gate wall. Your pressure gauge is changing. To control the outlet discharge, your pressure gauge value is vary. So you will set the 0.2. Okay. After setting the 0.2, how much amount of the vacuum pressure increased. Okay, that should be also noted in your tabular column. After that, you will take the collecting tank 10 cm of ice of time and then 10 blink of energy meter reading. That should, everything should be similar, followed in your repeated up to 5 times. Okay, you get the 5 readings and then get the efficiency of the reciprocating.